Welcome back, guys, sa data analysis. So for midterm, we're going to discuss the frequency measures and graphical representation of data. So, tutunan natin sa last prelim, no? Yung different variables containing different levels of information. So based on this, we can determine which statistical methods to use when analyzing collected information or data. So suppose we are interested in studying the employment opportunities and starting salaries of university graduates with a master's degree. So we make a variable x, okay, denoting the starting salaries measured in, for example, dollar to, no, dollar per year. Now suppose 100 graduate students provide the initial salaries. No? So yung n natin equals 100, no, yung total number of subjects to be interviewed or to be studied. Now, let us write down the salary of the first student, no? And the first student or the first respondent, we assign to him the X subscript, no? Subscript 1, okay? So X1 and then the rest, X2 until ma-reach natin yung last student, no? Si X100. So how can we summarize down, no, those 100 values based to extract meaningful information from them? So paano tayo makapag-extract ng meaningful analysis, no, from these 100 values, no? Remember, salaries yung ating subject for study, no? So the answer to this question depends upon several aspects like the nature of the recorded data, no? How many observations have been obtained? 100. Or how the data was recorded, no? So paano natin kinuha yung information through questionnaire ba or interview, no? So those three factors we can base, no, from those three factors how how we will approach the problem at hand. For example, the starting salaries may be obtained as exact values, say $51,500 per year, no? Or 32,350. Alternatively, these values could have been summarized in categories such as low income, medium income, or high income. So ito yung tinatawag natin group data, no? So another approach, yun daw yung first approach, no? Another approach is to ask whether the students were employed or not after graduating and record the data in terms of yes or no. So it is evident that the latter classification is less detailed than the group income data, which is less detailed than the exact data. Depending on which conceptualization of starting salary we use, we need to choose the approach to summarize the data. That is the 100 values relating to the 100 graduated students. Absolute and relative frequencies, discrete data. Let us first consider a simple example to illustrate our notation. So remember, ano yung absolute, ano yung relative, and ano yung frequencies, no? So yung frequency, yung collected information, no? Yung about absolute and relative, yun ang didiscussing natin ngayon. Yung discrete data, okay, remember, nung prelim, discrete data cannot be ordered in a certain logical manner. So, anong example natin? Nominal, no? Nominal variable. For example, male, female, no? Suppose there are 10 people in a supermarket queue. Each of them is either coded as F if the person is female or M if the person is male. The collected data may look like MF, F. So, 2, 4, 6, 8, 9, 10. We have 10 data na collected. And then, we can create two categories, no? Male, female. So we use A1 to refer to the male category and A2 to refer to the female category. Since there are 7 male and 3 female students, so we have the following data, no? We have 7 values in category A1, which is the male category, and denoted as N1 equals 7. So notice yung N is the number of frequency, no? Yung number of information, no? So since pito yung ating male or 7 yung male natin, so we will assign N1 as having the value of 7. And 3 values in category A2, tatlong ating female, A2, remember, is referring to the female category. So N2, we have 3. Okay, the number of observations in a particular category is called the absolute frequency. So, ito daw, N1 and N2 is called the absolute frequency. Okay, yung direct total at direct collected information, no? Absolute frequency ang tawag doon. It follows that N1 equals 7 and 2 equals 3 are the absolute frequencies of A1 and A2 respectively. Note that N1 plus N2 equals N equals 10, which is the same as the total number of collected observations. We can also calculate the relative frequencies of A1 and A2 as F1 equals F of A1 equals N1 over N. So remember, ginamit natin si category na male. Ito, hindi yan female. Yung F, yun ay function. No? So we use the variable F no, to represent the relative frequency no, of A1 and A2. So ano ibig sabihin nito? Si N1, since N1 si 7, at si N yung total number of ating observation, no? Then we will have 7 over 10 which is 70%. Ibig sabihin, 70% ng ating observation ay male and 30% no, ng ating observation ay female. So, this is what we call the relative frequencies. Okay? So, we just compute for the ratio of the different categories that we have created. Okay? And that in that way, we can get the relative frequency. We now extend these concepts to a general framework for the summary of data on discrete variables. Suppose there are k categories denoted as A1, A2 until AK, no? With NJ, J equals 1 to 2 until K, observations in category AJ. The absolute frequency AJ is defined as the number of units in the J category of AJ. No? So AJ is a category. Okay, so A1 to A2 is the number of frequencies, and AJ with NJ is we can determine the absolute frequency. And this is defined as the number of units in the J category, which is J equals 1, 2 until K. Then the sum of absolute frequencies equals the total number of units in the data is using the summation formula. Okay, so this is the starting K, the final number, the total number, which is K, and the J, which is the initial starting point. Then we will have Nj equals N. So the relative frequencies of J class are defined as Nj over N is equal to F of AJ. No? So yung ating relative frequencies using the concept no in general framework. Ibig sabihin nun, this is a general formula no without a specific example. Okay, so the relative frequencies always lie between 0 and 1. And the summation kj equals 1, uh, fj equals 1. And this is for under discrete variables. How about group continuous data? Okay, so pag discrete kasi, wala tayong fix yung ating value na exact siya. No? But with group continuous data, we have a different setup. No? Data and continuous variables usually has a large number of k of different values. So what do we have is a different formula for the relative frequency, which is fj equals 1 over n for all j. However, it is possible to define intervals in which the observed values are contained. So consider the following n equals 20. So we have the total number of observation of 20, which written part of a driving license examination. So we have the maximum 100 points, and we have the following total score, individual score. And we can summarize the result in a cluster such as 0 to 20, 21 to 40, 41 to 60, 61 to 80, and 81 to 100. And those are the categories that we have created. And the resulting table, as you can see, we have absolute frequencies here and the relative frequencies here. No? So nj equals 1, n2 equals 3. Okay, so meaning, under ng 0 to 20, merong isa, 21 to 40, merong tatlo, 41 to 60, merong tatlo rin. So, using this, no, as a basis for grouping each individual score, the resulting table is represented by this row, no, for the absolute frequencies. For relative frequencies, we only have to put the total, since we are computing for the ratio, no, we have to put the total number of observations, no, beneath the values, no, individual values. So we have 3 over 20 here, 3 over 20, 9 over 20, and 5 over 20. And using the summation formula, we have summation 5 j equals 1, then nj equals 20. Okay? But for the, this is for the absolute, no? And for the frequency, relative frequency, we have summation 5j equals 1, fj equals 1, no? So laging ang ratio nila is between 0 and 1. Now, suppose the ends observation can be classified into k class intervals, A1, A2 until AK, where j equals 1 and 2 and until k contains nj observations with summation k j equals 1 and j equals n. So the relative frequency of the j class is fj equals nj over n and summation kj equals 1, fj equals 1. So remember, the fj or the summation of the relative frequency always lies between 0 and 1. So table 2.1 displays the frequency distribution of a discrete variable x. So ito yung example, no, ng frequency distribution. So pag sinabing frequency distribution, we will have the following format, no? We will have the following table format. Okay? Example 213, consider the pizza delivery. No? So this will be an example using the R software. Remember yung ating diniscuss na statistical software, no? For automatically computing, no, the absolute frequencies and relative frequencies. So either manually or using the R software, we can have we should have the same result, no, on this table. So we have the center east west. We have the number of absolute frequencies for 421, 410. Under ng frequency, relative frequencies, we just have to put the total number of deliveries, no, done for the said period. Okay, so we have 421 over 1,266. Okay, so remember yung ating symbol. Anong symbol nito? Okay, estimated to be 0.33. Okay, sa ating calculus-based physics. So this means estimated to be this value. So for the absolute value or the absolute frequency, we have 1,266 deliveries, but for the relative frequency, we have 1. We go now with our last topic, empirical cumulative distribution function. So another approach to summarize and visualize the frequency distribution. Again, yung frequency distribution pertains to a table, the resulting table of our data with regards to absolute and relative frequencies. Yun ang sinasabing frequency distribution. Also, it refers also to the groupings or the categories we made, no? Like here, no? These are the categories, okay? Group data. So under that concept, how to summarize and visualize the frequency distribution of variables, no, under our previous example, no, is the empirical cumulative distribution function, often abbreviated as ECDF. So as the name itself suggests, it gives us an idea about the cumulative relative frequencies up to a certain point. O, define muna natin yung ating mga terms, no, words. Pag sinabing empirical, thorough study, ibig sabihin yung detalyado. Okay? Empirical, pag sinabing cumulative, ay yung total o yung accumulative, no? Accumulated value. Pag sinabing distribution, so we will it pertains to the table, no? Yung function, yan, alam niyo na yan, no? Often abbreviated as ECDF, ng empirical cumulative distribution function. So for example, say we want to know how many people scored up to 60 points, no? So in example 2, 1, 2, then this can be calculated by adding the number of people in the class intervals. Okay, so we have another groupings category. Ang ating ginamit na example, ito daw, yung 2, 1, 2. Yan, ito. Yan, example 2, 1, 2. Yan ating gagamitin data, no? So then this can be calculated daw by adding the number of people in the class intervals, no? 0 to 20, 21 to 40, so on and so forth, no? Which corresponds to n1 plus n2, again, the number of data, no? Number of observations. So we have 7 and it is the cumulative frequency. So remember, sabi natin cumulative yung accumulated na ipon, no, in Tagalog. So pag inipon natin yan, we will have the value of 7. So if we want to know the relative frequency of people obtaining up to 60 points, we have to add the relative frequencies of the people in the class intervals also. So we have 1 to over 20 plus 3 over 20 plus 3 over 20. Nilagyan lang natin ng total number of observation na sa ilalim as the divisor, no? So before discussing the empirical cumulative distribution function in a more general framework, let us first understand the concept of ordered values, no? Suppose the values of either four people observed as x1 equals 180, x2 160, x3 is 175, and x4 170. We arrange these values in order. No? So, pag in-order daw natin yan, okay, we have the following result. So, ano yung sinasabi nating ordered? Ano yung pwede nating i-order daw? No? Ano yung variable na yon? Yung sinasabi nating pwedeng order is the quantitative variables o kaya naman yung mga discrete, no? I mean yung continuous variables. Yan ang pwede nating i-order, no? So ang tawag daw dito kay x1 hanggang x4, they are called ordered values, no? For which x1 is greater than, I mean less than x2 and x2 is less than 3, x3 and less than x3 is less than x4, no? So, consider an observation x1, x2 until xn of the variable x, which are arranged in ascending order as x1 is less than or equal to x2. So, ay ganun yung relationship niya kasi naka-ordered, no? So, the empirical cumulative distribution function f of x is defined as the cumulative relative frequencies of our values aj. So, we have the following general framework, no? F of x is equal to summation of, okay, aj is less than x f of aj. Okay, if the function of f is equal to aj. This definition implies that f of x is a monotonically non-decreasing function. Okay, so hindi raw siya bumababa. 0 is less than or equal to f of x and f of x is less than or equal to 1. Limiting x is going to negative infinity, f of x is equal to 0. The lower limit of f is 0. Under ng limiting limits of x going to positive infinity, we have f of x equals 1. The upper limit of f is 1 and f of x is right continuous. So, ibig sabihin nito, positive going to 1 lang siya, no? Kasi ang limit natin sa under ng cumulative distribution function is always equal to 1. Okay? So, under yan ng undiscrete. No? Let's go now with the ECDF for ordinal variables. The empirical cumulative distribution function of ordinal variables is a step function. So, anong ibig sabihin ng ordinal variables? Again, sa prelim, remember, ang ordinal is any data which can be ordered but their difference doesn't mean anything, no? So, ibig sabihin nun, kahit i-minus natin sila, no? Or pag-compare, we cannot analyze it to those procedure, no? We can only order them, no? For example, not satisfied is equal to 1, 2 is equal to unsatisfied, 3 is satisfied, 4 is very satisfied, and 5 is perfectly satisfied. So itong 1 to 5 pwede mong i-order, no? Katulad ito, naka-order sila. But if you deduct for example, no, 4 and 5, no? Wala silang ibig sabihin there is na ano meaning, no? Wala kang makikitang meaning or hindi mo siya pwedeng i-analyze approach, no? So based on the frequency of each option, we can calculate the relative frequencies and then plot the empirical cumulative distribution function, either manually or using the R software, no? Hindi natin kinukuha yung difference nila. Tina-analyze natin sila by using the empirical cumulative distribution function, no? So how do we use this satisfaction level? Nakita nyo to? Satisfaction level AJ. So ito yung level natin. We have the absolute, we have the frequency, and we have the empirical. This is the empirical, no? So for the absolute, we only have to put the number of cases, no, under each category, no? So ibig sabihin nito, apat sa sumagot ng not satisfied, no? Ito. Sa number ng subject na sumagot ng unsatisfied, okay, ay 16. Yun namang number of very satisfied na sumagot is 90, no? So on and so forth. So, under ng empirical, I mean under ng relative frequency, no? We have to put the total number of data or observation, no, as a divisor. So 4 over 200, 16 over 200. But under ng empirical, we add, no? Cumulative kasi siya. So we add 4 to the next one. Okay? So that's how we get the 20, no? So 16 plus 4 will give us 20 over 200. 90 plus 20 will give us 110 over 200. 70 plus 110 will give us 180 over 200, and 20 plus 180 will give us 200 over 100. That's why under this example, we have fj is equal to 1, no? Kasi 200 over 200 is always equal to 1. Okay? So when we graph this, we will have the following representation. J's are calculated as follows. So ito yung ating computation, no, formula for the empirical, no, ACDF. Okay? So pag nakita kayo ng malaking F, that is not a relative frequency, no? That is the ECDF. Okay? So we only have to accumulate, no? Ito yung maliit na F, yung relative frequency. The empirical or the ECDF function is only equal to, can be defined as the accumulation of the relative frequency. Yun lang ang simpleng definition ng ECDF. So, under those concept, no, under that concept, yan, kahit basahin mo to, maintindihan mo siya ng madali, no? Kasi alam mo na siya ay accumulation ng maliit na f or the relative frequency. Huwag kayong malilito sa AJ. Si AJ is the category, no? Okay, si X yung variable natin. Yan. So, minus. Bakit natin mina-minus? O, kasi parang dun sa ating, sa ating calculus, no? Calculus-based physics. We have the limits, no? We are setting the limits of the individual steps, no? So, ito yung individual steps at ina-add natin, ina-accumulate natin yung kasunod na mga relative frequency. CDF for continuous variables. In general, we can apply formula to continuous data as well, no? So we only have the following, in using those formula, we have the following representation, okay, for the number of groups or intervals. EJ minus 1 lower limit, GJ upper limit, DJ equals EJ minus yung width of the j interval or the limits, okay, kung hanggang saan yung scope, and NJ number of observations in the j interval. Under the assumption that all values in the particular interval are distributed uniformly within this interval, the empirical cumulative distribution function relates to a polygonal chain connecting the points, no? So 0, 0, okay? So following this pattern, we will have the following result, no? E1, yan, cumulative na ulit ito, EDC, ECDF, F of E1, so on and so forth, no? Hanggang sa last data, okay? So, if we are going to use the summation formula, the same, no? Starting from 0, okay? F of x is equal to, okay? We have the following cumulative section of this polygonal chain, no? So, first polygonal chain, kinonect natin sa second polygonal chain until ma-reach natin yung ating final, no? Yung ating final data dito, no? So, starting from E0 until the final observation. With f equals 0, the idea behind is presented in 2 for any interval. Ito yung interval natin. The respective lower and upper limits of the ECDF are, okay, yan yung mga limits or pinagsamang lower and upper limits. If we assume values to be distributed uniformly over this interval, we cannot connect f. We can connect FEJ and FEJ minus 1 with a straight line. So, magkasunod lang kasi sila. To obtain fx with x is less than or greater than ej minus 1 and x is less than ej, we simply add the height of the ECDF between ej minus 1 and f of x to ej minus 1. So, remember siya ay limits, no? Ayan, no? Limits. So, pag pinagsama mo sila, pag pinagdeduct, you can determine the width or the scope of the, kung gaano siya kalawak, no? Kung gaano kalayo yung lower limit at upper limit. Under this illustration, we have the following graph. Under kasi ito ng general framework, no? So, wala tayong example. Ibig sabihin, ito yung general pattern, no, na mabubuo mo kapag sinunod mo ang cumulative or ang ECDF under ng continuous variables, no? Yan. Okay. So, pag continuous variable daw, magkakaroon ka ng chain. At kapag kinonect mo yon, you will have the lower limit and upper limit. Okay. So, EJ minus 1, this will be the lower limit. Okay. And upper limit will be somewhere here, no? Dito sa end ng ating graph. Yun yung graph, pero pag tinable mo, the values need to calculate the ECDF for the group P sa delivery time data will be represented like this. Okay? So, meron tayong groupings. Okay? So, lower limit, nasaan ang upper limit natin? Ito yung upper limit. Yung kanilang difference, kanilang width, no? Width. And then, yung ating frequency, relative frequency, and also the ECDF or the empirical cumulative. So, pinag-plus lang natin yan. Ayun. So, 0 plus 20.0024 will give you 0.024. Okay? Ito naman is yung, remember, ito yung number, I'm sorry, hindi ito yung width, no? Hindi ito yung scope. Ito yung number of frequencies, no? So, under daw ng group, no? Lower limit, upper limit. Okay, so 0 to 10. 0, no? Wala tayong na-collectang data doon, no? 10 to 15, tatlo yung pumasok, no? Na data. 15 to 20, 21 ang pumasok. Okay? So on and so forth. Okay? And under those data, we can compute for the relative frequency and then accumulate them under the ECDF. If we table them, we will the following representation. Okay, that's it for our data analysis, no? Midterm part 1.